What if the first clue to life on Earth did not begin on Earth at all? What if part of our story was hidden inside a rock older than our planet's oceans? In the darkness between worlds, one small asteroid carried a question scientists could not ignore. Its name was Bennu, and for billions of years, it drifted almost untouched through space. To most people, it looked like a dead stone. To scientists, it looked like a sealed message. NASA sent a spacecraft across millions of miles to touch that message without contaminating it. The mission was called OSIRIS-REx, and its target was not a planet, but a relic. Bennu is a leftover fragment from the early solar system, a survivor from cosmic construction. Long before forests, oceans, animals, or humans, Bennu already existed in the cold. That made it valuable, because old stones can remember conditions that planets later erase.
Earth changes constantly. Volcanoes erupt, oceans move, continents break, and evidence disappears. But small asteroids can preserve ancient chemistry, like a locked vault floating in silence. So scientists wanted more than a telescope image. They wanted a real piece of Bennu. In 2020, OSIRIS-REx descended toward the surface and performed a strange cosmic touch. It did not land like a rover. It reached down, stirred the surface, and pulled away. For a few seconds, a machine from Earth touched material older than human imagination. Then it sealed the sample, turned away from Bennu, and began the long journey home. Years later, a capsule entered Earth's atmosphere, carrying black dust from deep time. It fell through the sky, not as a meteor, but as a scientific time capsule. When it landed in the desert, the real mystery was only beginning.
The scientists had to treat every grain like evidence from a crime scene. One mistake, one fingerprint, one breath of contamination could confuse the entire story. Inside the container was not treasure in the ordinary sense. It was something stranger. It was dust, pebbles, and chemistry from a world that never became a world. At first, the sample looked simple, dark, fragile, and almost completely unremarkable. But under instruments, Bennu began to reveal a hidden chemical landscape. Researchers found carbon-rich material, water-altered minerals, and signs of ancient reactions. This did not mean Bennu was alive. It meant Bennu had preserved useful chemistry. Then came the discovery that made the story feel much bigger than one asteroid.
From the dust,
The sample contained amino acids,
one, a study in crystalline order.
molecules associated with the chemistry used by living systems. Some were familiar to biology on Earth. Others pointed to chemistry that did not come from biology. Scientists also detected all 5 nucleobases used by DNA and RNA here on Earth. Again, this was not proof of life, but it was proof of something deeply important. The raw chemistry connected to life can form in places far beyond Earth. That changes the question from did life begin here to how common is the setup? Bennu also carried evidence that water once shaped its parent body long ago. not oceans like Earth, but tiny ancient environments where minerals and liquids interacted. Scientists found salt minerals that suggest water evaporated over long periods, leaving crystals behind. That means Bennu may carry a record of a wet, transformed world that no longer exists. Somewhere in the early solar system, rock, water, and chemistry met in darkness.
But Bennu proves the gap between lifeless rock and living world may be more mysterious than we thought. And if one asteroid preserved this record, there may be countless others still waiting. Some are beyond Mars. Some pass near Earth. Some have never been sampled at all. Each one may carry a different chapter from the time before planets became familiar. So the question is not only where life began, but how much of it came from the stars.